Deposition, which is also called sedimentation, is the process by which sediments that are being carried by a transporting agent are dropped by that medium. So sediments like sand, silt, clay, pebbles, cobbles, carried by a transporting agent like running water, ice as a glacier, wind, are dropped by that medium, by the ice, by the water, the wind. Key word is dropped. Deposition begins with D, dropped begins with D. We discussed this when we talked about sedimentary rocks. You need deposition so that you have piles of sand or sediments all mixed together that can then be compacted or cemented to make a sedimentary rock. So we've discussed this already. Now deposition occurs, especially with running water, since that is the main transporting agent on Earth. Deposition occurs when the velocity of the water decreases. So you can see right here, in the background, you see a river, the Schmo River. And when the Schmo River opens up into a larger body of water, like Lake Ontario, Schmo Bay, you get deposition because the water in the river slows down, and as that velocity decreases, it drops off all the material that it was carrying, the sediments. That is deposition. Occurs with a decrease in velocity. Doesn't have to be a river, like right there, the Schmo River, going into Lake Ontario. It could be going into an ocean, any larger body of water. When the velocity decreases, the larger particles settle out first, and then the smaller ones later, and the tiniest of particles, the ones that are dissolved, the ions and the colloids, which you can't even see because they're dissolved in the water, will settle by the process of precipitation. And remember, we talked about that again with formation of sedimentary rocks. Precipitation. The tiny dissolved particles precipitate out, settle to the bottom. So there are a number of factors that can affect deposition, how fast things settle through water. First factor is size, particle size. Larger particles settle through water a lot faster than smaller particles. Smaller particles will settle more slowly. So obviously the size of those particles is a factor. The smallest particles, colloids, will remain in suspension as long as the water is moving. So if the water is moving even very, very slowly, they will remain suspended. It's only when the water is very still that they will settle out. Perfect example is mayonnaise. Mayonnaise is a suspension that has colloids in it. As long as you keep opening and closing the refrigerator door and moving the jar of mayonnaise, it's a suspension. But if you were to leave mayonnaise alone, over time, and it's not moved, over weeks and months, you would see layers separate out of the mayonnaise. Colloids, the tiniest of particles. So as with size, what you can see is over time, what you would get is the particles would settle out in horizontal layers, with the biggest on the bottom and the smallest on top. We'll talk more about that. A second factor that influences deposition is particle shape. So rather than drop different shaped rocks through water, it's just as easy to show with pieces of paper. You've probably already seen this before. I got 2 sheets of paper. I take one, I crumple it up into a spherical shape, like a sphere or a ball, right? And you drop it. You will see that the 2 sheets of paper, they do not fall at the same rate. The spherical one will go faster. The flat one, because of the air resistance, right, will slow it down. That friction, same thing in water, the friction of the water will slow it down. A third factor that influences deposition is density. So if I have cubes of different materials, so here's a cube of styrofoam, here's a cube of plastic, here's a copper cube. You already know, we've studied density, mass over volume. Styrofoam is very light, okay? Actually, it floats in water, so I won't use it in this demo, but I can use the copper and the plastic. Copper is a lot heavier, right? Has a higher density than the plastic. Watch the rates of deposition as I drop them in the water. Copper being heavier. Copper falls at a faster rate because of its greater density. So we just said as the velocity of running water or stream decreases, the stream will drop the largest particles first. That will create a pattern on the bottom of the stream bed that is referred to as horizontal sorting, where you have the largest particles drop first, smaller and smaller as you go out into the lake to the tiniest. So they are now sorted by particle size, and they're along the bottom of the riverbed in a horizontal line. Horizontal sorting. You actually may want to pause this and sketch this picture in the margin of your notes. Now if the deposition occurs very quickly because the stream maybe was flooded, right, what you will get is vertical sorting up and down. And to show or model vertical sorting, I've got this tube that's got different sized particles in it mixed with water. And if I turn it vertical up and down very quickly, shake it up, and go something like that, then what you'll see is the bigger particles end up at the bottom, smaller particles in sand up above, and then the tiniest particles, actually they have not even settled out yet because I'm still moving the tube, so I have to let it sit, and the tiniest particles will settle on top. Remember, those tiniest particles are called the colloids. If you want a chance to check this out, vertical sorting, it's also referred to as graded bedding. You can check this out in my classroom. I'll have this for you to hands-on mess around with. Now remember, when the stream is moving and it is carrying, eroding these particles, right, before deposition occurs, these particles are generally not moving the same speed as the water. Something like this is going to be rolling along the bottom a little bit slower than the water itself. The lone exception to that are the colloids and the dissolved ions that are actually in suspension or dissolved in the water, traveling with the same speed as the water. So to finish up this section on deposition, we need to talk about wind deposition and glacial deposition. And I don't have a really good place handy nearby that I can drive to take the video. So what we'll do is I'm going to use some PowerPoint slides, show you some images. But what I want to do first is when I talk about wind deposition, I want to review what we talked about with wind erosion. Remember, wind only moves the smallest of the particles, like sand and even tinier stuff, right? Because of the speed of the wind, how much it can actually pick up and move on a regular basis. And you tend to find this in like dry or arid climates. So that's why I don't really have like sand dunes and stuff near my house. Wind deposition can also create things called cross beds, so I'll show you an image of that. So that's wind deposition. And when we talk about glacial deposition, remember my nickname for glaciers. What is it? Hopefully you remember that. They're like a dump truck. Okay? So remember what we said about glaciers is anything can be frozen in a glacier, from like little tiny pebbles to cobbles to sand and tiny things. And then when the glacier melts, dump truck, it just drops everything, all unsorted, all mixed up, not layers. It's not like beautiful graded bedding or vertical sorting like we see in a stream. It's just all mixed up and unsorted. Glacial deposition.